Excellent. Okay, so I'm Mike Levy. I'm a software engineer in the oceanography section at NCAR. I was giving a status report on adding MARBL initially to the CSM implementation of MOM, but eventually we hope to feed this back to the standalone MOM as well. I've had lots of help from lots of people that I've named below, and I somehow managed to leave Alper off of this list, but he also provided lots of input along the way. So just a quick outline. I'll talk a lot about what MARBL is and how it runs. I'll give a brief overview of how we're going to have a couple MARBL into MOM. And then the bulk of the talk will be kind of the long answer to how does MARBL fit in MOM, and then a summary at the end. So this is a slide from 2017, just an overview on what MARBL is. It's a software library to add biogeochemistry tracers to ocean models. It's got a modular design, so it's independent of any GCM. Everything is done column by column, so we don't have horizontal operators. The project started in the fall of 2014 with the goal of sharing POP's BGC code with the MPAS Ocean, funded by a DOE grant. Just in case you're curious about the timing, the CSM Acme split, I first got wind of it in spring of 2014. So this was after that split was known to be coming, but I think MPASO was kind of seen as the front runner for CSM3 for the ocean model. And then we had this goal that in an ideal world, other GCMs would see this BGC library and want it too. And as you'll see from this talk, we're almost there. So the MARBL design principles were open development on GitHub, and I've provided a link to our GitHub repository. And we use it, so we use Fortran for all of our computation. And since this is part of CSM, we need to support a wide range of compilers. So I think Intel, PGI, G-Fortran, and NAG are the four that we test with. We're using Python for tools. Just the scripts, well, we provide a standalone driver for testing, and that's all managed by Python, even though it's Fortran code. We have tools for generating the parameter settings files and things like that. It's all Python based. And we also use GitHub to host our documentation. So there's a link to our GitHub IO page. Everything we do should be column-wise, and we have some requirements that we impose on the GCM. So the GCM will do all the IO for us, all the parallelization, the time stepping. There's some data that MARBL needs from one time step to another, and the GCM needs to save that for us. I won't go into detail about it, but we call it saved state, and I might mention it in a later slide. And then there are some cases where we do need horizontal operators, and the GCM needs to do that. So right now, the only example is if we want if we want to compute burial coefficients on the fly, then we need running means of global means, and the GCM needs to provide the global mean for us to do that. We use consistent units in MARBL. We're currently using CGS because this code originated in POP, which uses CGS, but we do have an issue to get open to look into switching to MKS. And then this picture, I think Matt Long put this in the initial proposal for MARBL back in 2013 or 2014, and it's kind of a good overview of what we're doing. So MARBL is the BGC model. It's this box down here, and then the base model just is the ocean model, and then we introduce a driver layer that belongs to the ocean model, like it's ocean model code, and it kind of does the translation between MARBL and the ocean model. So for this talk, pretty much everything I'm going to talk about is in this BGC driver box, and then I did have to make small changes in MOM's tracer flow control to call the driver code. but everything else is in its own module. So I guess Keith mentioned this very briefly in his talk, but MARBL adds 32 biogeochemistry tracers. There's an optional carbon isotope module that would add 14 more tracers. It computes surface fluxes such as ARC, CO2 flux, chlorophyll concentration. It computes source sink terms for the tracers, although the GCM needs to apply them. And then there is a standalone MARBL for some small test cases, and that's separate from the code that's run by the GCMs. It's basically a small driver for testing the shared code. So MARBL runs in kind of three stages. So in initialization, we set parameters and define tracers and diagnostics. Then every time step, we compute surface fluxes and interior tendencies on the source sink terms. And after each of those computation stages, we return a set of diagnostics. So there's diagnostics related to the surface flux computation and diagnostics related to the source sink computation. And then at the end, we shut down. We clean up memory space and make sure the GCM has received the final log. So this is kind of the short, how do we add MARBL to MOM? I've broken it up into two steps, the infrastructure updates and the Fortran updates. So on the infrastructure updates, and this is really, I guess, CSM MOM, but we need to create a COM set that will turn on the VHC tracers by default. We need to interact with MARBL Python scripts to determine parameter settings and what diagnostic gets output. I introduced a new parameter in the tracer flow control, use MARBL tracers. So we only add the tracers if this is true, and by default it's false, unless you're running with one of the COM sets that turns it on. At the request of GFDL, I added a compile time macro underscore use MARBL tracers, and we only build if we compile with this macro. So we don't distribute MARBL with MOM, but it'll be brought in automatically in the CSM version of MOM, and it's available freely on GitHub for the standalone MOM. And then we'll need to update the MOM diagnostic package to handle the MARBL output. On the Fortran side, these are kind of the big steps in my mind. It's not all inclusive, but we need to read the MARBL parameters from disk, because that's how MARBL wants to be configured. We need to call MARBL's initialization routine, and we do that from call tracer register. We need to call MARBL's surface flux compute and interior tendency compute, and we'll do that from call tracer column FNS. We need to add MARBL diagnostics to the desired output files, and then in tracer flow control end, we'll call MARBL's shutdown. So I'll interrupt just to give a progress report on where things stand right now, and then the rest of the talk will be the kind of more details on these bullet points. CSM can build MARBL as part of MOM. MOM adds all 32 of the MARBL tracers to the model. Right now, it's only passively affecting all the MARBL tracers. We're not applying the surface flux or source sink terms. And MARBL diagnostics can be added to the output, but it's not in a user-friendly way right now. It's very kludgy, and obviously that'll get cleaned up as this work progresses. And we do write MARBL log messages into the CSM log files. So just to have a picture to break up the blocks of text. On the left is the initial nitrate field at the surface that we read in the MOM initial condition file. And then after a month of being passively advected around, it's different, but obviously this is not like a meaningful scientific plot. It's just showing that MARBL is, or that MOM is doing something with the MARBL tracers. So going into a little bit more details, all of my testing is in the CSM framework. That's the primary focus for the initial implementation. And then once it's working in CSM, it'll hopefully be easier to go back and apply it outside of the CSM framework. I'm going to avoid showing any code snippets, but all the code is available in GitHub. In the CSM implementation, so there's MOM6 source code. Then there's also the MOM interface that sits between CSM and MOM. And I needed to update both of those layers to include MARBL. I've been trying to keep up to date with the CSM MOM development. So last week I merged in what were the latest tags at the time. I'm not sure if these will be the tags in CSM2 or if there's going to be one more set of updates. And then I'm trying to color code the progress on the following slides. So things that are highlighted in green are done. In yellow, they're in progress. In red, they're not yet begun. And if the colors look too close together, there's also the icons, a check mark, a construction, or a not yet done. I'm pretty new to PowerPoint. I can figure out how to change the bullet points themselves. So just appended those on the end. All right, so on the infrastructure side, we build MARBL, and this is done through CSM's case.build script, and which calls MOM interfaces build lib script, and that's done. Use MARBL tracers is in the MOM parameter list. The default value is false unless you specify an Ocean BGC config that is not none. And so I created the C1850 MOM eco comp set in CSM that sets Ocean BGC config to latest, which uses the most up-to-date tunings that we have. In progress, building MOM with the use MARBL tracers macro. So right now, my seam sandbox just has an update to include this flag whenever we build MOM. But on my list of things to do eventually will be to talk to our pair and also the seam developers about what behavior we actually want. So I could see keeping it so that CSM always builds MOM with MARBL, and that keeps MARBL as a runtime configuration. You can turn it on or off at will, but maybe we'd want to mimic kind of POP's build time configuration and have a flag that turns the build macro on or off instead. That's a discussion for down the road. It's not too important right now. Also in progress are providing initial condition and surface forcing fields. So there's a notebook in the MARBL forcing repository that we use to generate the initial condition files. Some of that fields come from World Ocean Atlas, some come from GloAdapt. Everything else comes from a CSM 2.1 PI control run for CMIP6. So here's surface nitrate on the native, I think this was a World Ocean Atlas grid, and then here it is interpolated onto the MOM grid. Again, and I guess I should have mentioned, this is all using the 2/3 degree grid that we've been developing CSM MOM with. Some surface forcing fields will eventually need to be written from files, but for those, I'm currently hard coding reasonable values instead of creating the files and figuring out how to read them in. There are some fields that come from the model, and those are being populated correctly. Like temperature and salinity are passed in from MOM6. Also in progress is tying into MARBL's generate settings file script to provide runtime parameters. So the CSM build MML script will generate a MARBL in file, but first there's no way to modify the values that get written into that. And secondly, it doesn't matter if you can modify those values because there's no Fortran code to read that file in and pass it on to MARBL. So that's, I guess maybe it's a stretch to say that that's in progress, but that's where that stands. I haven't done any work to tie MARBL's generate diagnostics file script, which can be used to provide a list of diagnostic output into the system. So far, I've just hard-coded specific tracers and one diagnostic into the diag table YAML file. And then as I develop, I'll continue to add diagnostics by hand as we need it. And I won't try to connect to the MARBL infrastructure until we're actually happy with where the Fortran driver is. And then I haven't done anything to tie this into the MOM diagnostic package. And this is really, I'm thinking about like the post-processing package, where if you do a run and then run some scripts to get output, if your run had BGC tracers in it, it'll be nice to have some BGC output. On the Fortran status, it kind of follows nicely in that how does MARBL run slide that I previously showed. There's some stuff done in initialization and some work to be done. I'm mostly focusing on the per time step work right now. And yeah, in the next slides, I'll go into a little bit more detail. And I think I mentioned this before, but in source tracers, so we have MARBL tracers at F90 is a new module that I created, and we call it from the MOM tracer flow control, and that's kind of the hook between MOM and MARBL. Okay, so tasks that I've finished. MOM6 gets a list of the BGC tracers from MARBL and call a tracer register. So when you turn on, when you set that use MARBL tracers flag to true, MOM6 adds 32 tracers to its list, and it initializes them and it backs them around. The hooks between the MARBL diagnostics and MOM6 are there on the Fortran side. So every diagnostic that MARBL can return is reported to MOM and tracer flow control in it. So in theory, you can add any diagnostic to the diag table, and it'll be spit out. In practice, we're still not computing all of them, so I'm not making all the calls into MARBL that I need to make. So in progress, computing the surface fluxes are getting there. All the calls to MARBL are in place. Some forcing fields are properly filled from MOM memory. There are other forcing fields that need to be read from disk or retrieved from the coupler. And I still need to tell MOM what to do with the surface fluxes. I mean, I feel like it's a little bit cheating to have that just be one bullet point, because that's a lot of work, but it's not there yet. And then a performance tweak. MARBL can compute fluxes from multiple columns simultaneously, but for like a simple first implementation, I'm just calling it column by column. Also in progress, so I've been allocating memory for things that MOM needs to hold on to for MARBL kind of as we go. And so there's some steps that I haven't gotten to yet, and so I haven't allocated memory for them yet. As I mentioned before, we can write all the diagnostics from the surface, from computing the surface fluxes, but the interior tendency computation is not called, and so those diagnostics aren't being accumulated. And then the MARBL log is being written to the csm.log file, but I don't think it's actually the right place for that. So at some point I'll move it to a more appropriate output file. And then still to do is reading the MARBL in file to get the MARBL tuning, the parameter settings, and pass those values to MARBL. And then still need to call interior tendency compute. It should be similar to the calling sequence for what we've done with the surface fluxes. Handling the vertical coordinate will be a little bit tricky. And that'll actually require an update on the MARBL side as well, because right now MARBL is used to pop just setting the vertical coordinate for every column during initialization and then letting it be. So handling a vertical coordinate that changes in space and time will require an update to the MARBL system, just to have an interface to do that. So again, the same disclaimer about all the output, that this isn't scientifically useful, but it's kind of a proof of concept that this is the CO2 piston velocity diagnostic that gets computed when we compute the surface fluxes, and it was accumulated over a month, because that's been the length of the test runs that I've done. And it was nice to see spatial variance in this plot. But when I was first running, I was setting temperature and salinity and all of the forcing fields to constants. And so MOM was just spitting out a constant field. But then once I was able to get spatially varying forcing fields, sent to MARBL, it was reflected in the diagnostic. And it seemed like a good step. So just to summarize, the MARBL driver is still a work in progress. Most of this infrastructure is in place for CSM, for the CSM MOM. MOM plus MARBL without CSM will be supported, and I'll do that work, but it hasn't been started yet. I have a few more MARBL calls to make, and also need to tie MARBL's like intent outs back to MOM, and I think that's it.